Hey crew, hey, today I'm going to go ahead and get 6.3 lesson completed, and today we're going to be working with equations. And so I've underlined the word equations because in this case we're going to actually be able to solve for it and get an answer. Equations will also have an equal sign in them. Remember, we had expressions before, so if I just had this value like 5x minus 3, I had to give a value for x to go ahead and simplify the solution. But I could put any number in for x and get a different value for y. So in other words, this term right here by itself is just an expression and hence doesn't have an equal sign. Then we're going to be working on the definition of a linear equation. Now, a linear equation, again, makes you think of line. And you might actually start thinking, wow, I remember a line. Sometimes we represent it as y equals mx plus b. And that's very similar to what they have written down here. It says a linear equation with one variable, x, is an equation that can be written in the form of ax plus b is equal to 0. So in other words, they have it as a constant, and so this is going to give me then one solution, or possibly no solutions if my x values canceled out. But in this case, when we don't confuse it with a linear equation, so a linear equation, we're going to have an infinite number of possibilities along that line and of different coordinates. We are going to be talking about the fact that when we solve for x, that we're going to get either solutions or roots. Boy, you've probably had from some of your math experience where we dealt with quadratic equations where it's x to the second power, and we found the roots of those equations. So those are also going to be considered the solutions. So today we're going to go ahead, in order for us to solve, we need to know a couple of properties of equality, and we kind of do these automatically when we did the other problems that we've had before. But the addition property of equality means that I can just, if I have a equals b, that means I can add some constant to both sides of my equation and I'm still going to be kept, they're going to stay balanced. The same thing with the multiplication property of equality, meaning that if I start off with two different numbers that are either equal to each other, I can keep my equations balanced just as long as I multiply both sides of the equation by the same thing. That means I can also divide or multiply times its reciprocal. So today our problems are going to look a little bit more like this, where we're going to solve. Now, they're going to go ahead, and you've got some examples up here where they work them step by step. We're going to go ahead and just jump down here to the example. And when we solve a linear equation, what we're going to do is we're going to start off by collecting all of the variables on one side and all the constants and the numerical terms on the other side. We're going to isolate that variable and then we're going to solve. So kind of to give you an idea of what we're talking about, this one right here, x minus 3 equals a negative 17, means that we have all the variables on one side. That means we just need to get the constants on the other side. So in other words, if I have a minus 3, if I'm taking x and I'm subtracting 3 from it, then I would want to do the opposite so that I just have x remaining. So I'm going to add 3 to the side, but I'm also going to have to add 3 to the other side. When this happens, that means on the left-hand side, my 3's cancel out. I'm left with just x. Then I would have negative 17 plus 3, and that's going to be a negative 14. Some of your books, when you were in algebra or pre-algebra, they might have had you do x minus 3 is equal to negative 17. And then they kept it linear, so they went x minus 3 plus 3 is equal to negative 17 plus 3. In other words, if you notice here, I'm adding 3 to both sides just like I did up here. It's just a different way to write it. They're still going to get x to equal negative 14. Now, either way you want to solve is fine with me, but I'll probably show you this one just because I have to write out less steps. The next one on I have x plus 12 is equal to 20. If I'm going to isolate my radical, that means I have to get the 12, move the 12 to the other side. If I'm adding 12, that means I want to do the opposite or subtract 12. And so in this case, I'll have x is equal to 20 minus 12, and that's going to be just 8. In the next problem, I'm actually taking x divided by 5 is equal to 3. And so the opposite of dividing by 5 would be then just multiplying by 5. And so when I multiply both sides of 5 by 5, my 5's cancel out. I'm left with just x. But then I'd have 3 times 5, which is going to be 15. Notice when I added and subtracted, I wanted to make sure that it was like I was adding x plus 0. But on this case, when I'm working on the division part, I want the leading coefficient of my x to be equal to 1. So I want to cancel out whatever is either multiplied or divided by that variable so that it equals 1. The next one, I have negative 6 times x is equal to 9. And so in this case, to solve, I'm going to go ahead and divide both sides by negative 6. And what happens is the negative 6 divided by a negative 6 is just going to be 1x, or x. And then notice 6 doesn't go into 9 evenly, which is fine, but you're just going to end up with a fraction. So in this case, I'm going to simplify my fraction. I'm going to have a negative. I have 9 over 6, which would be the same as 3 over 2 once I divide both by 3 and take out the common factor. My problems are going to get a little harder, so on the next one I'm going to do a combination of things. So I'm first going to start off by, I want to isolate the 5x, so that means I need to add 8 to both sides. So 72 plus 8 then would be then 80. So I have 5x is equal to 80, and then to finish I'm going to divide both sides by 5. So 80 divided by 5 would be 16. So x is going to equal 16. Let me double check that just in case as I hit x times 5. And it is 16. The next one, if we have parentheses, we're going to get rid of the parentheses first by distributing. So I'm going to take 10 times 3x plus 2, which would be 30x plus 20 is equal to 70. And then what I want to do is the same thing I did before. I'm going to move my constant, so I'm going to subtract 20 from both sides. So I have 30x is equal to then 7 minus 2, or 70 minus 2, and in this case I'm going to end up with 50. And so x then would be then 50 over 30. And then I'm going to simplify by canceling out my zeros. So x is going to equal 5 over 3. Keep in mind that is the same as 1 and 2/3, and that's the same thing. The next problem, I have a minus. I'm subtracting this whole term. That means I need to distribute the negative in. So I have 11x minus 6x, but I have a minus, and then I'm 5. So a minus and a minus 5 make it plus 5 is equal to 40. And then I'm going to say 11x minus 6x would be then 5x, because I'm just going to combine like terms on one side. And then plus 5 is equal to 40. The next step would be subtract the 5 from both sides. 5x is going to equal 35, so x is going to equal then 7. If I have variables on both sides of my equation, what I need to do is I need to move them to one side. And I usually always move my smaller amount. So in other words, in this case, I'm comparing the 2x and the x, and x is smaller, so I'm going to subtract x from both sides. 2x minus x gives me x minus 7 is equal to 6. And then to solve for x, I need to do the opposite of subtract 7. So I'm going to add 7 to both sides. So x is going to equal 13. If you have a combination, so in this case I'm going to distribute my 8, and so I have 8y plus 2 times 8, or 16, is equal to 2 times 3y, which is 6y, plus 2 times 4, which is 8. Now I'm going to go ahead and continue by getting my variables on one side of the equation. So I'm going to move my 6y, so I'm going to subtract 6y from both sides. And so I'm left with 8y minus 6y, which is 2y plus 16 is equal to then the 8. The next step would be subtract my constant, so I want to subtract the 16 from both sides. So 2y is going to equal 8 minus 16, or a negative 8. In the last step, if I have 2 times y, I'm going to do the opposite, a divide by 2 on both sides. So y is going to equal a negative 8 divided by 2, or negative 4. And this last problem, again, start off by distributing. So I have 10x minus 40 minus 2 is equal to 4x minus 12 plus 3. So the next thing I want to do is combine like terms on both sides of my equation. So I have 10x minus 40 minus 2 would be a minus 42 is equal to 4x minus 12 plus 3 would be a negative 9. And then the next step, I'm going to move my variables. So again, I'm going to move my 4 to this side. So I'm going to subtract the 4x to get my variables on one side. So 10x minus 4x is going to be 6x. Minus 42 is equal to negative 9. And then the next step is move my constant. So plus 42 to both sides. So 6x is equal to 42 minus 9. 42 minus 9 is going to be 33. And then I'm going to divide both sides of my equation by 6 to solve. So x then is going to equal v3, and the best thing I can do is just take out my common factor of 3. So I'm going to take a 3, so it's 11 out of 2. All right, and that will take care of this lesson. I've got another page. So one more. In a second, it'll be done with this lesson. So problems are when we deal with rational expressions. So in this case, if you notice, I have a rational expression, which it makes it look like a fraction, honestly. So what I want to do is I want to multiply through times my least common denominator. Notice on this one, I have only one denominator of 4. That means in order for me to solve, I would go ahead and multiply through times 4, or I can just go ahead and isolate this one and do that another time. So keep in mind, I'm going to show you how to multiply through times your least common denominator on both of these. This one, actually, I think moving my 9 and then multiplying it times my reciprocal of 4/3 would actually work as well. But let's go ahead and multiply through times 4, and I'll show you I'm going to get the same answer. When I multiply everything times 4, okay, if I multiply the entire equation times 4, that means I'm multiplying everything, okay? Every term has to be multiplied times 4. So the first one would be 3x over 4 times 4. But then I'm going to have to go minus 9 times 4, but then I have to go minus 6 times 4 as well. My 4's do cancel on my 3x, so I have 3x, but now I have minus 36, and then equals then 6 times 4, negative 6 times 4, which is a negative 24. If I add the 36 to both sides, so I have 36 minus 24 is the same thing as a minus 24 plus 36. So I have 3 is going to equal x is going to equal 12 divided both by 3. So x is going to equal 12 divided by 3, or 4. You want to make sure anytime you're dealing with a rational expression that it does work. And notice I don't have to worry about this in this case because I have numbers on the bottom of my fraction. When they become variables, which they do in college algebra, you want to double check and make sure that's part of your domain. Now the next problem I have denominators of 5, 2, and 6. And so I'm looking for my least common denominator between all of them. And in this case, I'm going to go ahead and multiply by 30, because I know if I multiply 30, then each of my denominators will cancel. So I'm going to go 30 times z over 5 minus 30 times 1 over 2. Then I'm going to go equals 30 times z over 6. Now, in this process, 5 goes into 30 6 times, and so I'm left with just 6 times z, or 6z. 2 goes into 30 15 times, so 15 times 1, so I'll have minus 15 times 1, or 15. And the last one, 6, goes into 30 5 times, so I'm left with 5 times z. Now my next step is I'm going to go ahead and subtract my 6c from both sides. And notice I told you before, I always try and do my smallest amount, but in this case it didn't work really well because my smallest amount was over here on this side and would have left me with 0 on the right hand side. So I'm just going to go ahead and keep it as a negative. So I have a minus 5 minus 6 would be a minus 1z, or minus z equals a negative 15. And then multiplying through or dividing by a negative takes care of a leading coefficient. So z then is going to equal negative 15 times a negative 1, or 15. There are times that you will run into problems where there's a no solution or there's an infinite number of solutions. No solutions mean when you solve it, your variables cancel out and you have a statement that is not true. On the other side, if you have a statement that is true, then you're going to have an infinite number of solutions. So let me take the first one. If I have 3x minus 7, and I distribute the 3 into this equation, I have 3x plus 3. My next step was to get my variables on both sides, so I'd subtract 3x from both sides. And notice they both cancel out, and I'm left with negative 7 is equal to 3. Because I have no variable, and this is not a true statement, I have a no solution, which would be the same as a null set. I'm going to put an or. Okay, in other words, no solution or null set. But look at this one. In this case, if I distribute the 3, I have 3x minus 3 is equal to, now on this case, I'm going to just simply combine my like terms. 8x minus 5x is 3x, but then 6 minus 9 is minus 3. Now you might notice right here that everything is going to cancel. And it does, if I subtract the 3x and keep going, I would have a negative 3 is equal to negative 3, which is a true statement. And I could still keep going and add 3 to both sides and get 0 equals 0. And in this case, this is an infinite many solutions. In other words, whatever you choose for x will actually work in this problem. Hey, we're done for this one. I hope you guys are having a good week.